Hey everybody, welcome to our 7.7 Solving Right Triangles lesson. Let's get going. Quick warm up here. Let's try to find G and H in this problem. Notice what we are given. We are given this segment of 19 and we are given the angle of 42. So if I'm going to find G right here, I have to note that from 42, all right, I am given this side, I'm given this side, I'm given the 19, so that side is adjacent to my angle. And if I'm going to use SOHCAHTOA, and I'm given the adjacent, I'm literally down to this or this. So I'm going to use cosine and tangent to find these values. If I'm going to find G, notice where G is. G is opposite of the angle. So to find G, I'm going to write down, that's going to be my tangent. I have opposite and adjacent. So to find G, I'm going to do tangent of 42 degrees will equal G over 19. And to go from there, we can cross multiply. We can set this tangent 42 over 1 and cross multiply right there. So I'm going to get that G is equal to 19 multiplied by the tangent of 42. And we're just going to type that into the calculator. We're going to type 19 tangent of 42 into the calculator. And when we do that, we find out that G is about 17.10. That would be the value of G. Now let's go find H. Well, H is right here. So H is this side. And again, I'm given the adjacent side. So now I'm going to be using adjacent, and notice that H is literally appropriately named because it's going to be the hypotenuse. So in this case, I need to use cosine to find the value of H. So for that, I'm going to use the cosine of 42 degrees. And that's going to equal, remember, cosine is adjacent over hypotenuse. So adjacent 19 over H. And again, we can make cosine of 42 over 1. And we'll cross multiply here. In this case, I'm going to get H times the cosine of 42. And that's going to equal 19. Well, obviously, that doesn't solve for H. So if I have multiplication, I have to divide. And I divide literally by the cosine of 42. And I divide that on both sides, and that goes away there. So now H, and I'm actually going to type that in the calculator. Let's type in 19 division cosine. I'll have a parenthesis there, type 42, and close it. And if you type that into the calculator, you'll get approximately 25.6 as the value of H. And let's double check that. Now, 25.6, notice that's the hypotenuse. 25.6 is bigger than 17 and bigger than 19. That's a common sense check. And if this is 42 degrees, that would be the smallest angle. So G should be the smallest side. So common sense check number 2. So this is just good review before we get started on our new topic today. So here's what we're going to talk about in today's lesson. Take a look at what I have here. I have that, and that. Now, you don't say that as, we don't say sin, we don't say cos, we don't say tan again. We say sine, cosine, and tangent. And that's not sine to the -1 power. That is actually sine inverse. All right? The blue one would then be cosine inverse. And in green, that would be tangent inverse. So that's the tangent inverse, cosine inverse, and sine inverse backwards. We are going to use these to find the angle measures of triangles. Like the triangle I have below here, notice I'm asked to find angle X. Angle X. Okay, so I don't know what X is. All right, but if you notice what I do have is I have this side, which is 4, and I have 8. Now 8, notice, is the hypotenuse. So I have the hypotenuse, and 4 is the opposite side. So if I were to think of my SOHCAHTOA options, all right, O and H, there's right there. I have to do the sine in this case. So what I'm going to write down is I don't know the angle. So I'm going to write sine of x, and that will equal opposite 4/8. All right. Now, the way I solve this is consider that I am looking at a situation where it's kind of like I have 2x equals something, or if I had x plus 2, or if I had x to the second power. Here I divide by 2, here I subtract 2, here I take the square root. All of those items I wrote in red are basically just the inverse operation. So what am I going to do to solve this problem? I'm going to use the inverse of sine, which is literally this symbol right up there. So I'm going to take the inverse sine of both sides. The inverse sine of both sides. Well, if I have the inverse sine of sine, they do just cancel out, and I'd be left with x equal to the inverse sine of 4/8. All right, and on your calculator, you will just use that same thing. So don't push sine, push second sine, and you'll see the sine inverse notation above it. And if you type that in, you will get exactly 30, and then don't forget that would be in degrees. Now, not every answer is going to be exactly a perfect number, but just realize we're using inverse functions here. Let's try some more examples. Okay, so here's another problem. All right, notice in this case, we're given the angle that's going to be right there. And consider that we have our SOHCAHTOA options. From that angle, again, notice that this 20, there's my hypotenuse. And what is 6? Well, notice that is the adjacent angle. Well, there's ka. That's the one that involves adjacent and hypotenuse. So then again, remember that that symbol is called theta. So I'm going to do the cosine of theta equal to the adjacent over the hypotenuse, so 6/20. Now again, I need to solve for theta. I need to eliminate this cosine. So what I do again on both sides is I take the inverse cosine of both sides. That eliminates the cosine. And now theta would be the inverse cosine of 6/20. And again, that's just typed into the calculator. And if you type that in the calculator, second cosine, 6 divided by 20, then close the parenthesis, you get approximately 72.5 degrees if I round to the nearest tenth. All right, now in this problem, notice that we are looking at trying to find two different angles in this case, two different angles. And so what we're going to do is take a look. Well, what are we given? In this problem, we are given the 14 and we're given the 17. So we are not given the hypotenuse. All right, so if you think about SOHCA and TOA, we're not given the hypotenuse. We're not given the hypotenuse. So that means I have to use TOA. I have to use the tangent. So let's start with x just because it comes in the alphabet first. And x from x, there is the opposite side. And this here, 14, would be the adjacent side. So if I'm going to do x, I'm going to say the tangent of x would equal 17/14. That's the opposite over hypotenuse. Now again, I need to remove tangent from that equation. So I will take the inverse tangent of both sides. That eliminates my tangents, and now I have x equal to the inverse tangent of 17/14. And again, we'll type that into our calculator. If we type that in the calculator, we get approximately 50.53 degrees for my value of x. Now, if x is across from 17, y is across from 14, we got to know that y should be a smaller value. So we could go ahead and use our tangent again, only in this case for y, I'm going to take that the tangent of y would equal opposite would be 14 for y, adjacent would be 17 for y, so I'm going to do 14 over 17. And we need to take the inverse tangent to solve of both sides. Inverse tangent, tangents cross out. So then y is equal to the inverse tangent of 14 over 17. And if we do that, we should approximately get y to be about 39.47 degrees. Now another way to look at this is we really didn't need to do trig for the second time. All right, I knew I had 90 degrees right there. We found out that x was 50.53. So really to find y, I could have done y plus 50.53 plus 90 would equal 180 degrees. And subtract those two away, and I still would get y to be 39.47. So again, you don't have to do trig. I just wanted to show more trig examples. All right, on this slide, I'm actually to find angle R. I wrote it over here, find angle R. All right, and if I want to find angle R, look at where R is. Right here, here's my angle. And now let's talk about this. So the 10 is the hypotenuse. The opposite side is 8. And 6 here is the adjacent side. So I can use all of them. Now to find sine, all right, so sine is so I would do opposite over hypotenuse. So sine of r would be 8 over 10. If I was going to use cosine, cosine is ca would be adjacent over hypotenuse. So that's going to be 6 over 10. And if I use tangent, that's toa, that would be then opposite over adjacent, and that would be then 8 over 6. Now if you look, you notice that I underlined each of those options twice. You can't see the red there. When I did. Now you don't have to do 3 times to find one angle, you just have to find one of them. But if you were to do the inverse sine of both sides to solve for r, up here, r would equal the inverse sine of 8 over 10. All right, type that in the calculator. If I was to do the cosine to solve r, in this case, r would be the inverse cosine of 6 over 10. And if I was going to do tangent here, I would use that r would be the inverse tangent of 8 over 6. And no matter what you do, no matter which of those 3 you would have found, all 3 gets you the fact that r would equal 53.13 degrees. So I just want to show you that no matter what you do, if you're given all 3 sides, you could do all of them, and each of them would get you the exact same angle. Obviously, in a problem, you'd only have to do it one time, so find the best scenario for you. All right, our next example, notice our instructions here to solve the triangle. Remember, if I say solve the triangle, that basically means find all missing pieces. So find all missing angles and all missing sides, okay? So if I look at my triangle, I'm given 22, which would be side Q. I'm given angle R. I would need to find a side R, which would be that side, and I would need to find side P, which would be this side. So I got to find 3 things. I got to find angle P, I got to find side R, and side P. Well, what are we given? I'm given this angle of interest, and from that angle, I know 22, which is the hypotenuse. So if I know the hypotenuse, and I'm going to use so, ka, toa, I know I'm going to be using sine or cosine, because those are the ones that involve the hypotenuse. So we'll not use tangent. And we'll actually end up having to use both in this case, because I got to do 2 trig equations. So I got to find sine, and from 37, that's the opposite side, and 22 is the hypotenuse. So the sine of 37 would equal r over 22. Like I did earlier, I would put that over 1, and then we would cross multiply, and r would equal 22 multiplied by the sine of 37. And if you type that in the calculator, you'll get approximately 13.22 as your length. Now to go find cosine, I would need adjacent, which is p, and hypotenuse, which is 22. So if I do the cosine of 37, that would equal p over 22. I can do the same thing where I set a proportion and cross multiply. And in this case, p is equal to 22 multiplied by the cosine of 37. And so if you type that into the calculator, you'll get approximately 17.56. And let's take a look. 37 would be the smallest angle, so then r must be the smallest side. All right, 13.22 is the smallest, and 17.56 is the middle. And then I got to find angle P, and if I just use that in a triangle, they all add up to 180 degrees, or realize that there's 90 degrees taken away there, so then these two angles are complementary. They add up to 90. Either way, you get angle P would equal to 53 degrees. Now I just want to make one more point here. I could have found 53 degrees first and then try to use angle P as my angle of interest, but there's a small chance that I could have made a mistake on finding this angle, and then if I found 53 as a mistake and tried to use the wrong angle to find other information, I'd be making one mistake 3 different times. So let's use the guaranteed info as we work ahead. So here's another one where, again, my instructions are to solve the triangle. So remember, that means find all missing sides, all missing angles. So I need to find this side, so I got to find side V, I got to find angle D, and I got to find angle V. All right? So let's first go ahead and find side V. So to find side V, I would do the Pythagorean theorem. So I'm going to have V squared plus 14 squared equals 20 squared. So that's going to get me V squared plus 196 equal to 400. If I subtract off the 196, now I'm going to get V squared equal to 204. And then we would need to take the square root of both sides to solve for V. And now I got to factor 204. So 204, what perfect square would divide it? Well, it would be 4 and 51. So the square root of 4 is 2. So I'd end up with 2 square root of 51 would equal V. So that's my side length. Now, I'm not going to use that to do any of my work because just in case I made a mistake, I don't want to make that mistake twice. Now I got to go find angle V. And if I'm going to find angle V right here, I would use the fact that 20 is going to be the hypotenuse and 14 would be adjacent to find angle V. So I'm going to do cosine of V would equal 14 over 20. Remember what we're using is, again, SOHCAHTOA. And to solve this equation for V, I need to take the inverse cosine of both sides to get rid of the cosine. And then V is going to equal about 45.57 degrees. Well, then to find angle D, all right, if I want to find angle D, all I really need to do is just do some triangles work where all the angles in the triangle add up to 180, or I can always know that the two acute triangles are 90. So I can just do 90 minus 45.57, and angle D will equal about 44.43 degrees. There's angle D, there's angle V, and I already found side V. I have solved the triangle. Last example here for the day, we'll do word problems. So we have a 20-foot ladder against the wall. So the first thing is to draw a picture. So let's pretend that this is my wall. and that this is the ground. Here is my ladder, and it is 20 feet. Picture is not drawn to scale, and I'm told the base of the ladder is 4 feet from the wall. What angle does it make with the ground? So what is my angle right there? I'm going to call it theta, and I have to solve it. So there's my picture, and now I need to solve it. So if I'm going to solve this, I got to look at it here. This is the adjacent side. That is the hypotenuse. So again, for so, ka, toa, adjacent and hypotenuse. So the cosine of theta of the angle is going to equal the adjacent 4 over 20. Well, again, to solve, I have to get rid of the cosine. So I have to use the inverse cosine of both sides to get rid of cosine. And now theta is going to be the inverse cosine of 4 over 20. And you type that in your calculator. If you type that inverse cosine, so again, second cosine into the calculator, you should get that it's about 78.46 degrees. And that would be our angle. All right, that is it. Here's your homework assignment for this. Have a great day. Good luck.